Hi, my name is John Reedy. My Grantham ID number is G00146838. Today I'm going to present you my Capstone project. For my Capstone project, I designed a motorcycle security device which detects unwanted movement and sends a text message to your phone. I chose this as my project because while traveling, I saw a need to be able to be warned if somebody was messing with my motorcycle while I was not around. In this video, I'm going to give you a demonstration of the system and its components. I'm going to run through and explain each of them, and then I'm going to go through the code step by step and explain what the code is doing, and then after that I'm going to give a demonstration of the system as it's functioning. The system consists of primarily 5 components. You have your Arduino microcontroller, you have your GMS module, and then you have your GPS with a built-in antenna, and there is a siren, which is optional with the on-off rocker switch. The Arduino Uno is great for prototyping systems, which is why I chose it, and it is going to stack directly underneath the SIM900 GSM module. Vibration sensor, which I forgot to mention, and on the side you'll see right here I created a power rail, which is just to share the ground source and the voltage source off of the Arduino microcontroller, which runs all the way over here, and then that way I can power all my subsystems. The antenna picks up the signals for the GPS, and you have your antenna for the GSM module, and to power it, it's going to be simply connected through the USB port right here, and it will come on automatically. The vibration sensor is powered through the 5 volts supplied by the power rail, and the green line is the digital out, which sends the signal to the microcontroller through the GSM shield of whether or not the vibration has been detected or not. The blue wire is from the GSM module, and it's going to go over to the serial line or serial port for the microcontroller, and the same with the yellow line, which is going to be coming from the GPS. And what that does is the blue line receives data from the microcontroller and it tells the GSM module when to send the message, and then the yellow line is the information coming from the GPS, which will be fed into the microcontroller to be sent with the message sent out through the GSM. The orange line goes to the rocker switch, which when you have it set to the on position, it dictates whether or not the siren is armed or not. So you can turn it off or on depending on how you want to use this system. But this is essentially the whole system, and let's discuss each one of the components. The system components, as mentioned, is the microcontroller, which is Arduino Uno board, which is great for the prototyping. On the bottom side of the GSM, you have your SIM card, and it has to be activated and unlocked. It comes with an antenna, and it's going to stack directly on the Arduino Uno. So all of these connections are essentially piggybacked off of these. The GPS device has an antenna built in, or it comes with it, and it works off a line of sight, so it has to have direct line of sight in order to work. Otherwise, it's just going to feed in zeros for your data. The vibration sensor is a digital, has a digital out and a ground and a voltage source. Those are the only 3 lines. And I have the code set up so that it detects a certain level. Once a certain level is detected, it will trigger the system to send the text message. So this is what picks up the unwanted movement. There's a built-in siren, and it's quite loud, and it works off of a rocker switch. So if you don't want to use it, you just turn it off, and if you want to have it armed, you turn it on, and it just works off of digital high or low. The SIM module with your SIM card in is going to stack directly on top. And that just provides a power source for all the components. The vibration sensor is going to be set to pin 3, 0, 1, 2, 3. We're going to plug the siren into ground. And it's going to be set to pin 4. Each one of these devices gets a 5 volts from the microcontroller, and the GSM module is also powered by the microcontroller as well. And we want the receive line to be from the GSM module to be connected to the transmit line from the microcontroller, and the opposite for the GSM, so the GPS. The GPS is going to have a transmit line connected to the receive line of the microcontroller. Now when you download the code, you have to make sure that these 2 lines are not plugged in, or else it'll give you an error because I'm using the software serial port. That way, if I want to test and debug the system, I can use the system and watch what's going on through the software serial while it also is using the function off of these 2 lines. Alright, so getting into the code is pretty simple. Up at the top you include your tiny GPS library. That is a library that brings in all the functions for the GPS and allows it to work, which we're going to see later in the code. We're going to create the object for the tiny GPS plus, and then you're going to move down and we name the pins to pin numbers. So pin 3 is going to be your vibration pin, pin 4 is going to be the alarm pin, and pin 9 is going to turn on the GSM using software. We set up the vibration measurement process, which will turn out to be the variable measurement, which we're going to use that later to compare to the number that we set it at. Your baud rate for your serial begin, and then we move down to the void setup, which we're going to declaring pin modes. I'm going to turn on the serial, or the SIM 900 serial via the software, which we're just basically going to turn pin 9 low, high, and then back to low, and then that's going to turn it on through the software. And also on the board, 2 junctions were soldered together to allow that to happen. You're going to start the software serial port at the GPS default baud rate that we set at top, and that's going to be serial begin. And then you're going to go into your main loop, which is void loop, and we're going to measuring the vibration sense. So we're going to take the function we set up earlier for the measurement, and we're going to call on that. And then while the serial is available, we're going to take the GPS encode, which we get this from the tiny GPS library, and we're going to read that information and we're going to decode it. And I have it set up to where if you're watching the serial print or the serial monitor, it is continuously printing the GPS. That's just a visual indication of, for testing, being able to tell when we've made connection with the satellites. Parameters to send in the text message. Now, if the measurement is greater than 20,000, we are going to set the GSM module in text mode, which is done with the AT commands. The mobile number to send the warning message to, again, AT commands, and then the warning message that gets sent. And then afterwards, we're going to send the location, the text needed to make it a link to Google Maps. We're going to send the date, time, and the speed, and then the serial print line char 26 to exit. Put some delays in there just to give it the time to run through all of his code. And then separately I set it up to where the parameter to set an alarm, and you could theoretically set that up to be different measurements. So if you wanted the alarm to go off even if it didn't send a message, you can manipulate those numbers, but they're both set to 20,000, and it is going to write the alarm pin high if greater than 20,000, else it's going to keep it low, which makes it not make any sounds. And that is the code. I'm now going to demonstrate how the functionality works. We're going to leave the rocker switch set to on, so we will get a buzz whenever the system picks up vibration. The GPS is setting close to a window, which it needs to have the line of sight to receive satellite signals. We're going to look for a green LED light to be blinking. We're going to look for a status light underneath here to be blinking every 3 seconds, indicating that it's made connection to the network. And then I have the receiving phone sitting here so we can wait to see how long it takes to receive a text message indicating that somebody has been tampering with your motorcycle. So it's going to be powered off my laptop, which will work just the same as a wall outlet or plugged into the USB power source from a motorcycle. Once powered on, we see 2 LEDs come on. We're going to wait to see for this one to blink every 3 seconds. And it is. If it had no connection to the network, it would blink every 800 milliseconds, which would be much faster, indicating that there is no connection. You can see that the green LED is blinking for the GPS signal, indicating that we have made connection with satellites and should be receiving all of our data. So let's give it a little test. And we received a signal, a message. And it has everything except for our longitude and latitude. Let's wait a little while longer and see if we pick up. It takes a little while sometimes for it to connect to the satellites. And there we go. We have our satellites with longitude and latitude. So let's turn that off. The system is set up to be pretty sensitive because once it's installed on the motorcycle, it has a hard time sensing vibrations as it does directly right on the system. So you can see there's a link that you receive with the warning message showing the longitude and latitude of your the location of the motorcycle, the date, the time, which is 4 hours ahead of time of the current time zone. That issue has not been resolved yet, and it has a speed, which is showing that we're not moving. So let's click on it. And this is our current location, which is basically where I'm at, so it's very accurate. Now let's give the system a little test without the alarm. I turn the alarm off. There we go. It works again. No siren. That way, if you wanted to keep it as a silent system, you can, and you get your location. I've completed all my testing for my device, and I've concluded that it works and functions as intended. The only thing that would need further develop would be the power source. The prototype right now is very power hungry. The final device would need to be a bare bones, stripped down version, maybe using a smaller Arduino Pro Mini or just a self-built microcontroller. And to make the system better, during the testing I realized that it would be a good idea to include a RFID sensor to detect when the owner is near the bike. You could leave it plugged in at all times, and when it senses that ID for the tag, it would know not to send a text message. And once the owner gets a certain distance away and it's not sensed, it would know to arm the system and send a message if the motorcycle is moved involuntarily or by somebody tampering it or whatever the conditions may be. In conclusion, the system works as intended and has been a success.